Hello and welcome back to the channel Science, Math and Engineering. Today we are going to solve the GATE Mechanical Engineering paper 2012 part 3. So let's get started. So here we have 15 questions from 41 to 55. These are all 2 marks question, and with this we will solve the technical part, the mechanical part of the GATE 2012 Mechanical Engineering paper. The only part that will be left is the aptitude and English part. Okay. So question number 41. Water with Cp equal to 4.18 kilojoule per kg Kelvin at 80 degrees centigrade enters a counterflow heat exchanger with a mass flow rate of 0.5 kg per second. Air with a Cp of 1 kilojoule per kg Kelvin enters at 30 degrees centigrade with a mass flow rate of 2.09 kg per second. If the effectiveness of the heat exchanger is 0.8, the log mean temperature difference in degrees centigrade is. So this is a counterflow heat exchanger. We need to find out the log mean temperature difference. So the answer is the hot water enters at 80 degrees centigrade, cold water enters at 30 degrees centigrade. So mass flow rate of hot water is given 0.5 kg per second and mass flow rate of cold water is 2.09 kg per second. This is given coefficient of cold water, that is the Cc, that is Cp of air, that is 1 kilojoule per kg Kelvin is given, and Ch is for hot water, that is our water, that is 4.18 kilojoule per kg Kelvin. Now effectiveness is given as Q actual divided by Q max. So Q max is equal to now here m dot c, that is mass flow rate, into the C specific heat of the whichever has the smaller heat capacity that we take, and then we have Th1 minus Tc1. See, the concept is that what is the maximum heat that can be transferred. Now if we take the maximum temperature difference, that is Th1 minus Tc1, so whichever has the smaller heat coefficient, no, that can on smaller specific heat, that can only get to this temperature difference. That means the cold water can, the cold air that can become from 30 degree, it can become 80 degree, and the hot water can become from 80 degree to 30 degree. So that difference can only be attained by the one which has lower specific heat. Okay, so that's why Q max is equal to m dot c into m dot c, the S, that is the smaller of heat capacity, into Th1 minus Tc1. So Q max here, smaller is for air, so Q max is m dot c into Cc Th1 minus Tc1, and our Q actual would be m dot c into Cc Tc2 minus Tc1. Okay, so from here we get our effectiveness would be equal to Tc2 minus 30 divided by 80 minus 30. So from here we get Tc2 is equal to 70 degree centigrade. Now we know Q actual is also that m dot h into Ch Th1 minus Th2, okay, which is equal to this one. So the amount of heat lost by the hot fluid is equal to the amount of heat gained by the cold fluid. So from here we get Th2 is equal to 40 degree centigrade. Now delta T at inlet would be how much? Th1 minus Tc2, that is 10 degree centigrade, and delta T exit is equal to how much? Th2 minus Tc1, that is again 10 degree centigrade. Since these two are equal, so the log mean temperature difference is then 10 degree centigrade. Okay, so we'll go to the next question. A solid steel cube constrained on all 6 faces is heated so that the temperature rises uniformly by delta T. If the thermal coefficient of the material is alpha, Young's modulus is E, and Poisson ratio is nu, the thermal stress developed in the cube due to heating is. So you need to find out the thermal stress developed due to heating. Okay, so the answer is C. Now the cube is constrained. Okay, so the cube cannot expand with a rise in temperature. This results in development of a compressive force on the walls of the cube. Due to symmetry of the cube, sigma x equal to sigma y equal to sigma z is equal to minus sigma. Now this epsilon x equal epsilon y, epsilon z equal epsilon. Okay, this is the string. So let L be the length of any side of the cube. Now without constraint, what would have happened? It would have happened is that delta L would be equal to alpha into L into delta T. So the strain on any side, okay, epsilon is equal to delta L by L, which is equal to alpha into delta T. Now volumetric strain, okay, would be equal to epsilon x plus epsilon y plus epsilon z, which is equal to thrice of epsilon, so 3 alpha delta T. Okay. Then with constraint, now what is happening is that already you know sigma x equal sigma y equal sigma z equal minus sigma. So volumetric strain epsilon v would be 1 minus 2 nu in by E into sigma x plus sigma y plus sigma z. Okay. So this is the formula. So from here we know that sigma is minus sigma x, all these are minus sigma, so it becomes minus 3 sigma 1 minus nu by E. Now this volumetric strain and this volumetric strain, these are equal. So from here we get 3 alpha delta T is equal to minus 3 sigma 1 minus 2 nu by E. So we have sigma is equal to minus alpha into delta T into E divided by 1 minus 2 nu. Okay. So we'll go to the next question. A solid circular shaft needs to be designed to transmit a torque of 50 Newton meter. If the allowable shear stress of the material is 140 megapascal, assume a factor of safety of 2, the minimum allowable design diameter in millimeter is, okay, so you need to find out the minimum allowable design diameter. So the answer is, see, T is given as 50 Newton meter. Tau allowable is 140 megapascal, factor of safety is 2. So the maximum stress tau max would be equal to how much? Tau allowable divided by factor of safety. This is the allowable, so this much is like this tau allowable is means what it can withstand, but tau max, that is the maximum that we can provide, is then tau allowable divided by factor of safety, that would be 70 megapascal. Okay. Now polar moment of inertia J for this rod would be pi by 32 into d to the power 4. Okay. Next, T by J is equal to tau by R. This is the relation that we have. So from here we get T divided by J, we already know pi by 32 into d to the power 4. Okay, and this D would be D minimum then. Okay, is equal to tau max divided by R is what? D min by 2. So from here we get pi by 16 into d cube mean is equal to T by tau max. So from here we get d mean is equal to cube root of 16t divided by pi into tau max. So it is equal to, we know T torque is already 50 Newton meter. So we get from here 15.379 millimeter. So d mean is approximately equal to 16 millimeter. So I have actually observed, I have also mentioned here d mean, because as we are saying that the minimum this diameter we need to, because after we get this approximation, we should be understood that this is the D minimum diameter. Okay, so it has to be at least greater than this. So it should be at least greater than this. So it would be around 16 millimeter. Okay. So we'll go to the next question. A force of 400 Newton is applied to the brake drum of 0.5 meter diameter in a band brake system as shown in this figure, where the wrapping angle is 180 degree. This wrapping angle is 180 degree. If the coefficient of friction between the drum and the band is 0.25, okay, so the brake torque applied we need to determine. So the answer is, we know T1, this one is T1 and this one is T2. So T1 by T2 is equal to e to the power mu theta. So T2 would be equal to 182.375 Newton. Okay. Now braking torque is equal to T1 minus T2 into R. So which is equal to 400 minus 182.375 into R is what? 0.5 by 2, which is equal to 54.406 Newton meter. So option B is the correct answer. So we'll go to the next question. A box contains 4 red balls and 6 black balls. 3 balls are selected randomly from the box one after another without replacement. The probability that the selected set contains 1 red ball and 2 black balls is, so this is a problem of probability, and here we are not replacing these balls. Okay, so see, let R be the event of drawing a red ball at random from the box and B be the event of drawing a black ball at random from the box. Now 1 red ball and 2 black balls can be taken from a box containing 4 red balls and 6 black balls at random without replacement, as you see it can be red, black, 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 red, black, and black, black, and red. Okay. Now the probability of these three would be, first if we take red ball, so our, and what is the probability? 4 out of 10. Okay. Next, to be a black ball, it would be 6 out of, only 9 is remaining, so 6 out of 9. Plus again black ball, so 5 out of 8. Plus, you see, now black ball, so it is 6 out of 10 into 4 out of 9 into 5 black balls only out of 8. Okay. Next, if we have black, black, and red, then what we get? We get 6 out of 10. Okay. Then 5 out of 9, and then now we have 4 red balls already there, so 4 out of 8 balls. So now if you see, all this equate to 1 by 6. So we have probability of this one of our 1 red ball and 2 black ball is 1 by 6 plus 1 by 6 plus 1 by 6, that is 1 by 2. Okay. So answer is 1 by 2. So we'll go to the next question. Consider the differential equation x squared d square y by dx square plus x dy by dx minus 4y equal to 0 with the boundary conditions of y0 equal to 0 and y1 equal to 1. The complete solution of the differential equation is, so you need to find out the complete solution. So the answer is, see, we are given this equation. Okay. Now how we need to solve that is given. I am putting it here, a basic structure. So we assume x equal to e to the power z, and then from here we get that this part x square d square y by dx square would be equal to d into d minus 1 into y, and dy by dx is just d. So d is dy by dx, so that way. So if we transform it, we get d into d minus 1 plus d minus 4 into y is equal to 0. So from here we get d square minus 4 into y equal to 0. So auxiliary equation becomes d square minus 4 equal to 0, which implies d is equal to plus minus 2. Now the complete solution is that y equal to c1 e to the power 2z plus c2 e to the power minus 2z. Okay. Now after this complete solution, if we will first put the value of x here. Value of z is what? See, x equal to e to the power z, right? So from here, when we put, we get c1 into x square plus c2 into x to the power minus 2. Okay, why is that? So y equal to c1 x square plus c2 by x square. So y0 is equal to 0. So you have, what we have is that c1 0 is equal to c1 into 0 plus c2 by 0. So we have c2 equal to 0. Okay. Next, y of 1 equal to 1. We have c1 equal to 1. So our equation is y equal to x square. Okay. So we'll go to the next question. We have a set of equations x plus 2y plus z equal to 5, 2x plus y plus 2z equal to 5, and x minus y plus z equal to 1. Okay. We need to determine whether this system of algebraic equation has a unique solution, only two solutions, infinite number of solutions, or no feasible solution. So the answer is So we first make it in the matrix form. Okay. Now the determinant of this matrix would be 0. Now triangle 1 is when we put this part B1, B2, B3 here, and then the next parts. So again we get delta 1 equal to 0. Next we get delta 2 equal to 0 and delta 3 is also equal to 0. Now as all these determinants are 0 and the main determinant is also 0, so the system of equations have infinite number of solutions. Okay, so we'll go to the next question. Two steel trusses AC and BC, each having cross-sectional area of 100 mm square, are subjected to a horizontal force as shown in figure. All the joints are hinged. Okay, here is the figure. All joints are hinged. F is 1 kilonewton and the magnitude of the vertical forces developed at B is what is we need to determine. So there is the first question. The second question is that what is the maximum force that can be applied at C such that the axial stresses of any of these truss doesn't exceed 100 megapascal. Okay. So the answers are, you see, first we need to determine the forces that are being applied here. Okay. Now see, F of CA into sine 45 degree would be equal to F of CB into sine 60 degree. So from here we get F of CA is equal to root 2 divided by root 3 F of CB. Again F of CA cos 45 degree plus F of CB cos 60 degree would be equal to F. So from here we get F of CB is equal to 2F by root 3 plus 1. Now as with our first question, it was given that F is 1 kilonewton. We need to find the vertical force developed at point B. See, so F is 1 kilonewton. So F of CB is 0.372 kilonewton. Now R of BY, if you see, R of BY is this one. This is how much? This is sine of F of CB, sine 60. So F of CB is sine 60, so which is equal to 0.63 kilonewton. Okay. Next, we have given cross-sectional area and the minimum axial shear stress in any truss is 100 megapascal. Okay. So the maximum force in any truss would be equal to then 10 kilonewton. Now, you see, F of CA is equal to root 3 by root 2 F of CB. Therefore, F of CA is greater than F of CB. So, if one has to, like, if we need to limit the maximum stress, then we need to limit the maximum force also, as the cross section area is same. So the F of CA, which is the greater one, which should have a maximum of 10 kilonewton then. So then F of CB would be equal to, from our equation, it is 8.165 kilonewton, and then we can find F of CB is 2F by root over 3 plus 1. So you can find F is a maximum of 11.15 kilonewton. Okay. So this is how we need to solve this. So we'll go to the next question. A refrigerator operates between 120 kilopascal and 800 kilopascal in an ideal vapor compression cycle with R134A as the refrigerant. The refrigerant enters the compressor as saturated vapor and leaves the condenser as saturated liquid. The mass flow rate of the refrigerant is given. The properties of the refrigerant are also given. So first, initially this is for saturated and this is for the superheated refrigerant. Okay. So the questions are, first question, the rate at which heat is extracted in kilojoule per second, that is in kilowatt, from the refrigerated space, that we need to determine. And next question is the power required for the compressor in kilowatt is, we need to determine the power, right? Okay. So let us first draw the TS diagram. Okay. So the answers are, see, initially we will draw the TS diagram. So this is point 1, from 1 to 2, this is the compression. From 2 to 3, this is the condensation. 3 to 4 is the throttling process, and from 4 to 1, this is the heat addition or the evaporator. Okay. So H1 is what? The entrance of the refrigerant in the compressor. So it is said that the refrigerator enters the compressor as saturated vapor, okay, and that pressure is 120, right? So at 120 saturated vapor, the enthalpy is 237 kilojoule per kg. So H1 is 237 kilojoule per kg. Okay. Next, this 3.3 is the point where this condenser exits. The refrigerator exits the condenser. So what is said is that the refrigerant leaves the condenser as saturated liquid. And saturated liquid and that pressure is 800 kilopascal. So saturated liquid HF would be 95.5. So our H3 is 95.5 kilojoule per kg. Now 3 to 4 is a throttling process, so H4 and H3 the enthalpy is same, so H4 is again same, so H4 is 95.5 kilojoule per kg. Now the rate at which heat is extracted in kilojoule per second from the refrigerated space would be, as this is the evaporator, this is the refrigerated space, so it would be m dot into H1 minus H4. So now H1 we know, H4 you know, m dot you know. So from here we get the heat extracted is Q dot is equal to 28.3 kilowatt. So we'll go to the next question. The next question is the power required for the compressor. So compressor is this one. From 1 to 2 it is the compressor. So H1 we know, we need to know the H2. Now if we go to the table, we see that says superheated refrigerant at this 800 kilopascal is how much? Is 276.45. The enthalpy is 276.45 kilojoule per kg. So this 1.2 H2 would be then 276.45 kilojoule per kg. So power required from the compressor would be P is equal to m dot into H2 minus H1. M dot into H2 minus H1. So from here we get power is around 7.89 kilowatt, which is approximately equal to 7.9 kilowatt. So we'll go to the next question. Air enters an adiabatic nozzle at 300 kilopascal, 500 Kelvin with a velocity of 10 meter per second. It leaves the nozzle at 100 kilopascal with a velocity of 180 meter per second. The inlet area is given. The specific heat is given. So the exit temperature of air is to be determined and the exit area of the nozzle is to be determined. So you see that we know that this total energy is conserved. So Cp into T1 plus half of U1 square would be equal to Cp into T2 plus half of U2 square. So from here we get T2 would be equal to 484 Kelvin. So that gives us the exit temperature. It is C 484 Kelvin. Next, we were asked the exit area of the nozzle in centimeter square. Now, we know R is Cp into gamma minus 1 by gamma. From here we get R. So we can determine rho 1. Rho 1 would be P1 by R into T1. Then we can similarly we can determine rho 2. Using continuity equation, we have rho 1 into A1 into U1 is equal to rho 2 into A2 into U2. That is m dot 1 equal to m dot 2. So from here we can determine A2, which is equal to 12.9 centimeter square. So we'll go to the next question. For a particular project, 8 activities are to be carried out. Their relationship with other activities are and expected durations are mentioned in the table below. So we have the activity, the predecessor, and the duration. As you can see, A is the activity, it has no predecessor. B, C, and D have a predecessor of A. E has a predecessor B. F has a predecessor D. G has a predecessor C and E, and H has a predecessor F and G. So what we are asked is that we are asked what is the critical part for the project, and secondly we are asked if the duration of the activity F is changed from 9 to 10 days, then what happens to the critical part. Will it remain same or will it increase or decrease? So first we will make this graph, that is the critical part method we will use. So A is the first one, then from A, B, C and D goes. Before B there is E, before F there is D. So like that we make this CPM. So from here we for every activity we mention the earliest time and the latest time that is required to do this to do the activity. No, so A has earliest time also 3, latest time also 3. So in 3 days it has to complete only. So when we do that, we find that this is we have to first find the critical path. So our critical path is A, D, F and H. So this is the critical path. So here we do not have any extra time. So this we have to do in time, and others like here B, it has earliest is 7 and latest is 8. So we can have a one extra day for B if we please. Similarly, if B is on time, we can give another day to E, so that even there also the critical path doesn't change. Now, as the duration, we ask that if the duration of F is changed from 9 to 10, now F lies in the critical path. So, if the duration of F increases from 9 to 10, the total critical path length, which was 18 days, would now become 19 days. So if it is changed, duration of F is changed from 9 to 10, then our critical path remains the same, but the total duration increases from 18 days to 19 days as F is in the critical path. So with this we conclude the GATE 2012 mechanical engineering paper technical part, and we will come up with the aptitude part later, and also we will be coming up with the next GATE 2013, 14 and so on papers. Thank you for watching. Bye bye.